Okay, yeah, a very good evening to all of you. In this particular session, we are going to solve few questions based on the week 5 content that is just been over right now. Okay, we'll solve the questions in such a manner, we'll solve those questions in such a manner that we are able to solve the assignment question. I'm not going to solve exactly the assignment question, but we can solve few of the questions which can lead us because which can make things easy for us while solving the assignment number 5. Okay, so let's get started. Yeah, so the topic which are covered in the week 5, there we discuss about the chirality, type of the symmetry operation that is been available in crystallography, and the relation between the cube and tetrahedron, what kind of symmetry they are holding with each other. Those things has been discussed. After that, the roto-inversion and how the roto-inversion we can one can prove it using the matrix multiplication, symmetry transformation matrix we are talking about. Then there was something about the invariance of the trace, which is very useful for us while dealing with the rotational symmetry specifically. Then the concept of crystallographic restriction theorem and its proof with respect to both geometrically and by the matrix, symmetry transformation matrix, where we have used that using this equation, we have proved that in the lecture by Professor Rajesh Prasad, it's been proved that the how we can derive the crystallographic restriction theorem. There was a crystal which was seemed to be deviated from the crystallographic restriction theorem, and yeah, it is deviated from the crystallographic restriction theorem, and it has given the new class which is quasicrystal because it was diffracting, it was giving the sharp spot in the diffraction, and these were the concepts which we have discussed in the week 5. Let's move ahead and try to solve few questions based on this particular concept. So the what this question is telling, let's read it first properly. I think it is visible now. Yeah, so employing matrix multiplication, we have to use the matrix multiplication. Demonstrate that the axis of intersection of the two perpendicular mirror correspond to the two-fold rotation axis. Okay, so they are talking about the two perpendicular mirror and their axis of. They are telling that okay, prove that the axis of intersection is nothing but a two-fold rotation axis, and this is what we need to prove using the matrix multiplication or the geometrical. Okay, so first of all, let's say that this is our x-axis, this is our y-axis, and this is our z-axis. Okay, so let us say our mirror is along the this xz plane, and also mirror is along the yz plane. So they are the two mirrors which are perpendicular with each other. And what is the axis of intersection? Axis of intersection is nothing but a z axis, this particular. And we need to prove that this is nothing but a two-fold rotation axis by the matrix multiplication. Okay. So what we will do, we'll take some general point. Okay. We'll write a matrix symmetry transformation matrix for the two mirrors. We'll write it for the two perpendicular mirror, and we'll also write this for the two-fold along Z. And if they are equal with each other, their this matrix, if they are equal, exactly same with each other, then we will say that okay, yeah, there is always a two-fold along the two perpendicular mirror. Okay, so let's start. So first, let us take the mirror xz. Let's take this particular mirror. What this mirror will do? How this is going to transform our x, y, and z. Okay, this is what we do in the matrix multiplication, symmetry transformation matrix. So let's take a symmetry transformation matrix for the mirror along x, z, xz plane as a mirror. So what this mirror is going to do, it is not going to change x in any way. So x will remain as it is, 1, O, O. But for the y, it is going to change y to the minus of y. So O minus of 1 and O. What about the z? Again, this is going to remain same, O, O1. And this is what we have obtained for the mirror along the xy. Sorry, xz. Now, in the similar manner, we can do for the yz mirror. That is this one. What this mirror will do to the x, it will transform x to the minus of x. So we have to write minus of 1, O and O. Y is not going to change in any way, 1, O, O. And the z will again remain as it is, O, O1. And this is what we have obtained from the two mirror. But we need to, for a particular point, mirror 1 has did something to this particular point. Mirror this particular yz has did something to this particular point. So if we want to know the combined effect of it, what we need to do, we need to take a multiplication of these two. Okay, and that's how we will get the first part, that what symmetry transformation matrix for the combine these two operations. Okay, so I will write this particular mirror, this particular symmetry transformation matrix in the next page, and exactly same it will be, and we'll try to multiply it. Okay, so let's start. So we need to write W, which is nothing but W of YZ and W of XZ. We need to do their multiplication. Let's write it. For XZ, we know that X was remaining same, Y was changing 0, minus of 1, 0, O, O, 1. For XZ, X was changing, that is minus of 1, O, 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 1, O, 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 1. So let's multiply them. First row, first column, minus 1. First row, second column is nothing but 0. First row, second column is 0. First row, third column, again 0. Second row, first column, 0. Second row, second column, minus 1. And then 0. Third row, first column, 0. Third row, second column, 0. And third row, third column, 1. Right? And this is what we have got the for the two perpendicular mirrors. Now our second thing that we want to know about for the two fold along the z-axis, what it is going to do. Okay, so now let's write further that we know for the any rotation how we write if it is along the z-axis we are rotating cos theta. It will be cos theta minus of sin theta o o o o 1. This is how I remember usually. Twofold means the rotation by theta angle will be nothing but 180 degree. We have to substitute 180 over here. Cos of 180 is nothing but minus of 1. Sin of 180 is 0. O 0 minus 1 O O O 1. This is what we have obtained after the twofold. Twofold along Z. And this is what we have obtained for the perpendicular mirrors. So as we can see, their symmetry transformation matrix they are exactly same. And that's how we can say for any object which is having the two mirrors perpendicular with each other, at the intersection point there will always be a twofold. Okay, and by the geometry one can prove. We have proved it by the symmetry transformation matrix multiplication method. And that's how we have solved the question number 1. Now let's go to the question number 2. Let me read it for you. What we have to do over here, that question is telling us that draw stereographic projection for the 6 bar Roto-Inversion and writes its symbol. Okay. So we have to draw the stereographic projection for the sixth bar, which is nothing but sixfold and inversion. Okay. So let me make a circle. Since we are talking about the sixfold, it means that we are going to rotate by 60 degree, right? So we will cut it in such a manner that we can easily do the 60-degree rotation, just like uh, a slice of a pizza. Uh, yeah, it's okay. It's not that bad. So six fold we are talking about. Sixfold means that sixfold means that n is equal to the 6, and we know that how we are going to, by what angle we are going to rotate. It will be the 360 divided by n, which is 6 over here, which is nothing but 60. So by 60 degree we are going to rotate. Let's start with the particular point. Let us say this is our initial point from where we are going to start. So what we have to do, we have to rotate by 60 degree. We'll come to this particular point, but we don't have to, our point will not lie here right now. We have to invert it also. Operation will only be completed if both the things are been done. So from here, we have to go back. We have to invert it. Inversion, let us say this is the point about which we are inverting. So this is the inversion point. Let me mark with the blue color. So from this, when we invert, we will get to this particular point. Since it is above, it will go below. So this was our point 1, and let us say the handedness is R. Okay, 1 R. So point 1, right handedness. But after the inversion, we got second point, but it will be the handedness will change, right? So for the mirror, in the case of mirror, and in the case of inversion, handedness will change. So we will get the 2 L. Now again, we got this particular point. Again, we have to rotate by same thing, by the 60 degree. Always remember that the sense of rotation will remain same. Whatever you are following once, I am following the counterclockwise. I will follow the counterclockwise always. From here, I have to go by 60 degree. I arrive to this particular point, right? Now from here, my rotation is not completed yet. Sorry, my rotation is completed, but the operation is not completed yet because the inversion is left. So from this particular point, I have to invert it. So once I invert, I will get to this particular point. This was below the, so this will be above. This we have got third point, and it will be, this was the left-handedness, so we will get the right-handedness over here. Now again, from this particular point, we'll go by the 60 degree. We arrive to this particular point. Again, we'll invert it from this to here. This was the above, so we will get the below. So it will residing on the same particular point in the stereographic, the way we are projecting it. But this is the below, so they are the two separate points. So here I am getting for this one, whole one, it is a point number 4. This was a right-handedness. This will be the left. After inversion, handedness will change. Okay. So now again, let's again rotate the entire thing. From here, this particular hole will rotate by 60 degree. Again, we'll invert. Since this was below, we'll get to this particular point. This will be above. And this particular point, which is inside of it, I should have used some other color for the inside one. So this particular point is nothing but point number 5. This was the L, so it will be right-handedness. So this was above, right? So now this was we got above. We'll rotate it by 60 degree again. We'll get to this particular point. This was above. We'll invert it. We'll get to this particular point, which will be below. And this we will call to be the point number 5. So this point number 6. This was the right. This will be the left-handedness. Now again, starting with this particular point, let's go to the 60 degree over here. This was below. Let's go over here. Invert it. We'll get to the above. And this is the left-handedness, right-handedness. So this will be the we got to the same point, initial point. So the our operation is complete. So following with the question number 2, let's do the particular proof by the symmetry transformation matrix. So using the symmetry transformation matrix, we have to prove that 6 bar is equal to the 3 over m. Okay, so this is what we need to prove. We just now proved that when we were having the 3 6 bar, how the things were looking like. Okay, we started with the point this, and we got all the points. All these 6 points we have got. And we want to know that 6 bar is equal to the 3 over m. Okay, so what we will do, we'll write the coordinate of all the 6 points, how they are going to look like. Okay, so 6 point we have to write. Starting with the first point, let us say point number 1 was x, y, and z. How the point 2 will look like if we are following the 6 bar for a time being. Later on, we'll go for the 3 over m also. But for now, let's stick with the x, y, and z with the 6 bar only. So whatever we will discuss for a time being will be 6 bar. So how this x, y, and z is going to change if I apply the 6 bar to them? What will be the next coordinate x dash, y dash, and z dash will be? This is something which we need to find. So for that, we need to find the symmetry transformation matrix for the 6 bar. We can do that very easily. For the 6 bar will be the nothing but the product of the 6-fold, then followed by the inversion. So how for the 6-fold we can write? 6-fold is nothing but theta is equals to the 60 degree. So let's write for that. It will be the cos of 60 minus sin 60, 0. Sin of 60, cos of 60, 0, 0, 0, 1. Now for the inversion, 1, 0, 0, 0, 1, 0, 0, 0, 1. Is it correct? No. Minus is associated with all the ones. Now let's do the multiplication of it. What we are going to get. Once you multiply them, oh, let's write the value also. Better we do in the next page. So you have to write for the 6th power. -1 0 0 0 -1 0 0 0 minus of 1. Here will be cos of 60 is root 3 by 2. Sorry, cos of 60 is 1 by 2. Sine of 60, which is root 3 by 2. 0 0 1. It will be root 3 by 2. 1 by 2 0 0. And that's how we just have to multiply them and we can find the symmetry transformation matrix for the 6th power. Let's do it at minus of 1 by 2. First row first column minus of 1 by 2. First row second column plus of root 3 by 2. First row third column. What we will get? 0. Second row first column. Second row first column we will get minus of root 3 by 2. Second row second column will get minus of 1 by 2, then 0. Second row third column. Third row first column 0. Third row second column is 0. Third row third column is minus of 1. This is what we have got for the 6. Now, starting with the point x, y, z, what will our point will be? X dash, y dash, and z dash. After we rotate by the symmetry transformation matrix, which is representing by this. So what we have to do, we have to multiply x, y, z over here. And we will get our x dash, y dash, and z dash. Let's do it. So first row multiplied by the entire column. So the first thing which we will get is minus of x by 2 root 3 times y by 2, and thus we will get z is 0, so the number associated with the z is 0, so no need to worry about it. Same will go for the second one. Minus of root 3 by 2 times x minus of y by 2, and for the z it will be transformed to the minus of z. So this is how our x, y, and z are changing. So x, y, and z has transformed to the minus x by 2 plus root 3 by 2 y. Y has transformed to the minus of root 3 by 2 x minus of y by 2. Okay. So this was x, this is y, and z has transformed to the minus of z. Due to that, this is happening due to the inversion itself, z to the minus of z. And this is how we have obtained the first point. Now on this second, This was the point number 1. This is the point number 2 which we have obtained. On this point number 2, if we apply our rotation again, roto inversion, we'll get the point number 3. On the 3, we'll get the point number 4, 5 and 6. So on and so forth, we'll get the all 6 points which we question number 4. No, here we will do the entire operation which I just told you about. What the question is telling that determine the coordinates of the equivalent point obtained after the 4 bar roto inversion assuming the starting point to be the xyz. So you have to find the equivalent points, their coordinates obtained which is obtained after 4 bar roto inversion. Okay, so 4 bar is there and we know 4 bar is nothing but the 4-fold and the inversion. Let's make the stereograph for that. This is the point, center. This is 90 degrees, so I will cut it in the vertical manner, vertical and horizontal. Let's say this is our starting point. Again, we'll go by the counterclockwise. I define some one thing and I'm just sticking to it. Now, let's rotate it by the 90 degree. We'll get over here. Operation is not completed yet, so we have to invert it right now. From here we'll invert, we'll get to this particular point. This was, let us say, point number 1 and right handedness. It was above. Here we are getting the below. After inversion, above will convert to the below. Top will go to the bottom. Since this is the inversion, we'll get the handedness will change and this will be 2. Okay, so let's stop right now for before we complete the stereographic position. So what we have done, so what we did is we did the fourfold and then we did the inversion. Starting point was x, y, and z. How can we get the final point? That is point this. This one was x, y, z. We want to know this particular coordinates. Coordinate of this particular point. X dash, y dash, and z dash. We will get this after the symmetry transformation matrix multiplications. Right. So this is something which we need to find. W4 and WI. Let's write for the W4. Fourfold. Cos of 90. We are rotating by 90 only. Then sine minus of sine 90. 0. Sine 90. Cos 90. O, 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 1. Just plug out their values. 0, minus 1, 0, 1, 0, 0, O, O, 1. This is we have obtained W4. Symmetry transformation matrix for the fourfold rotation. Now we have to go for the inversion. And we know inversion is very simple. That is, all the values x will change to the minus of x, y will change to minus of y, and z will change to minus of z. And we need to find this x dash, y dash, z dash, which will be multiplication of this with our this particular one, which was, I'm just writing the same thing, that is this one. Over here. And our initial point was x, y, and z. Let's do simple matrix multiplication. What we will get? First row, first column, 0. First row, second column, 1. First row, third column, 0. Second row, first column, 0. Second row, second column, 0. Second row, third column, 0. Third row, first column, 0. Third row, second column, 0. Third row, third column will be nice, minus 1. X, y, and z. Now after this, after we have multiplied the things, we will get the x dash, y dash, and z dash. Let's do that. It will be nothing but y Did I made any mistakes? Let's check for the second row again. Second row, first column. Oh, it will be minus of 1 over here. Instead of 0, it will be minus of 1. My mistake. So we multiply this with this. We got y. Then it will be minus of x. And this will be minus of z. And that's how it is transforming. It transforms from x, y, z to y, x bar, z bar. And this is happened by the 4 bar. This is one of the equivalent point we have found. Now, this point we have found. This is nothing but x. No, this was a y, x bar, and z bar. Now, considering this to be our initial point, what we have to do? We have to rotate it again by 90 degree. We'll get over here. We have to invert it. This was the left handness. This will be, let me write with the black color. This will be right. This was below. After rotation and everything, it will be above. And this is our point 3. In the similar manner, the way we start from the 1 and we got to the point 2, the same thing we have to do for the this also from this. See, we have already obtained what is the symmetry transformation matrix for the entire part. This is the one. This is containing the information about the 4 bar. So we don't need to do this entire multiplication again. We just need to do that. We'll take this W, that is the O 1 O minus 1 O O O minus 1. Our final point which we have obtained was x minus of y minus of x minus of z, and it will be equal to the new point. Let us call that x dash y dash z dash. Do its multiplication again. What we will get? This will be minus of x then will be minus of y, and after that it will be plus of z. So our initial point, which was x, y, z, it got transformed to the y, x bar, z bar, and then again it got transformed to the x bar, y bar, and z. This is how our transformation is taking place by the 4 bar. So now we have again obtained the coordinates of this particular one. Similar manner, you can obtain the for this particular point also, which you will get after the fold 4 bar rotation and inversion. And that's in that manner we have seen that there will be the 4 equivalent points, and we also write the coordinates of the 3 equivalent points. Similar manner apply for this particular point which we have obtained, that is x bar, y bar, and z. Apply 4 to this, invert it, you will get this particular point. And in this manner we can solve the question number 4. Now let's move ahead and go to the question number 5. So what question number 5 is asking, that identify the symmetry operation. We have to identify the symmetry operation over here. In the case 1, we can see that the flower is made up of the this 5 things. So it is having, if I rotate this entire thing about this particular axis, vertical axis, after from this, we can see there are the 5, by the 5 way we can rotate it. That is, we have to rotate by 52 degree. So this is having the 52 degree. After 52 degree, it will repeat. So this first thing is having the 5-fold symmetry. Even though our crystal, not the quasicrystal, I'm talking about the true crystal. Those cannot have the 5-fold symmetry, but our real object in the nature can be found that 5-fold symmetries are existing. What about this second figure? Don't confuse with the saying that okay, this is a tenfold because there are the 10 leaves are there. No, they are, two of them are clubbed with each other, all two of them. So again, this is a 5-fold. What about this? The glass consisting of the wine. If about this axis passing through its center, if I rotate, in how many way I can rotate it without affecting its symmetry, without disturbing its shape? There is an infinite way. Just rotate slightly or by some any angle, 1 degree, 2 degree, 3 degree, anything. It will remain as it is. So it is having the infinite fold of symmetry. Now what about this cat? We can see it is not a mirror because this is upside down. Considering this to be the inversion standpoint about which we are inverting, we can say that yeah, about this particular point, all the things, all the features are getting inverted. So this is having the point of inversion. Let's go to the next figure. In this figure, we can see that there are the one mirror vertical. There is another mirror which is horizontal. Is there anything else? There is. This is a mirror. This is a mirror, and both mirror are perpendicular to each other. So we can say that yeah, there will be the twofold, twofold rotation will be there. Consider this particular point rotated by the 120, rotated by the 180 degree, that is twofold, will get to this particular point. They are exactly symmetrical with each other. They will coincide, and that's how we can do it. So this is having the two perpendicular mirror with the twofold. No, What about this? This is having the rotation followed by the inversion. You can visualize this. This is nothing but a tetrahedron itself. We can visualize this in the cube. Considering this point will be this two. Considering this 2 point will be this two. Okay. Rotated by the 90 degree about this particular axis. That is along this particular axis. You get to this. Invert it, you will get this. Take this, rotate by 90 degree, you will get over here. Invert it, you will get it over here. Rotate by 90 degree, you will get it over here. Invert it, you will get it. 90 degree inversion, initial point. So this is having the fourfold followed by the inversion. So this is 4 bar. And that's how we can solve the question number 5. Now, let's move to the question number 6. The question number 6 stating that, okay, in a cubic closed pack system, we have the CCP system, cubic closed pack. The lattices are rotated about the 1, 2, 3 rotation axis. Okay, so about this rotation axis 1, 2, 3, they are rotated about the 90 degree about this particular axis, which is 1, 2, 3. The rotation is about the 120 degree. In the primitive basis, okay, in the FCC there we can find the primitive basis also. Calculate the trace of the symmetry transformation matrix. We have to find the trace. Trace is the sum of the body diagonals. Sorry, trace is sum of the diagonal elements. But do we need to construct a primitive basis? Go with this particular axis and rotate it by the 120 degree, applying all the symmetry transformation matrix and all the geometry visualization and which we can do. Should we go with that particular way? No, there is no need. We know that trace of the matrix, symmetry transformation matrix, is invariant. It is not going to change. It only depends upon the theta, the angle about which is rotated. It doesn't depend upon the axis about which it is rotated. It doesn't depend upon the basis, like in what basis system we are rotating it. It doesn't depend upon that. So simple what we can do, since it is independent of these things, we will make our cube simple cube without worrying what will be its primitive basis and all. We can say that this is x, this is y, this is z. We can rotate about the z about by 120 degree and we can find the trace. We can construct the symmetry transformation matrix itself. So let's do that. X, y, z. About z, we are rotating by 120 degree. We can write the cos of 120. So trace will be sum of this 2 cos of 120 plus 1. Cos of 120 is nothing but 2 times minus of 1 by 2. It won't be 3 by 2. It will be 2 times 1 by 2 minus of 1 by 2 plus of 1. This got cancelled. Minus 1 plus 1, it will be nothing but 0. And that's how we have solved this. Okay, my pen is down. Let's do in the next page. And we know the trace of the for the rotation matrix, we know that it is 2 cos theta plus 1. And theta here is 120 plus with 120 degree. Cos of 120 is minus of 1. So 2 times of minus 1, that is the minus of 1 itself. Sorry, 2 times of minus 1 by 2 is minus 1 plus 1. It will be equal to 0. So we obtain the trace without going into the primitive basis, without worrying about this particular axis, and it will be 9 minus 1. Simple way. For rotation, for the pure rotation, always apply the 2 cos theta plus 1 in order to find the trace. And that's our question number 6 we have solved. So now this is our the final question. We need to do the math the following. So here are the 5 symmetry elements. So here are the 5 symmetry elements. Identity, yeah, it is also one of the symmetry element. Mirror plane, axis of rotation, center of inversion, roto-inversion. We have to find the invariant point will form. See, every symmetry elements, when we are talking about the point in point group, they will leave something invariant, right? So what it is? So what? Let's first talk about the rotation. For any rotation axis, if I rotate, all the points on this particular axis is going to remain same. They are not going to be changed, so they are invariant. So in the case of axis of rotation, we see that there is a line, 1D line, which is invariant. So we can match with this. If something is having the center of inversion, entire space is gonna change other than this particular inversion point. So there will be the one point which is not gonna change in the inversion. So center of inversion, single point. What about the mirror plane? For the mirror plane, we know that all the things which is above will go to the bottom. All the things which are at the bottom will go to the upper side. But the points which is lying onto the mirror, they are not gonna change. They are invariants. So the plane which is consisting of all the points, invariant point, will be the invariance itself. So in the case of mirror, we will have the 2D plane which is invariant. What about the roto-inversion? If I talk about the roto-inversion, let us say this is the axis about which we are rotated. Okay, once we rotated, everything is on the axis is as it is constant. They are not changing. But once I inverted about one particular point, let's say this particular point, once I inverted it, what will happen? All the points above will go to the bottom and all the points of bottom will go to the on this particular axis. So except this particular point, all the things are getting changed. So since we have added the inversion, the only one point is invariant right now. So it will again connect with a single point. And for the case of identity is gonna change nothing. Identity is a nothing is no operation itself, no changes. All the things will remain as it is. Take this and rotate by 180 degree. Again, we have got the same thing. In whatever space I rotate, everything it's gonna change nothing. So it is everything is invariant in the case of identity. So we'll say that okay, yeah, a 3D is invariant, and that's how we have solved the all these 7 questions. Okay, so with that, I hope that all the questions of the assignments you will be able to solve, and we can wind up this particular class. If there is any doubt, you can always ask on the dot forum, and also you can comment on the videos if you wanna ask something. Okay, okay. So with that, let's meet in the next week.